right, so we are recording. Let's verbally do attendance. Let me start from the bottom here again. David, Hodges, Sipple's here, right? Yep. So for the video, Sipple is here presently, physically. Eric, Midkiff is here wearing red. Butler, Polly, Rice is here. Cedric, Richardson. I don't know why I want you to be Richardson. I'm sorry. Richardson is here. I guess it's just because you're always in that direction. Both of you are in that direction. Anyway, Richardson's here. Samuel's not here yet. Newton, Burdette, Hudson's here. Felder, Tudor's here in red. Asbury I saw is online. Bowers, Hemmings, Redmond in red. Reed, Michaela is here in red. Taylor is here. Van Cross. All right. So everybody here is accounted for physically, right? Didn't miss anybody? All right. All right. We've got a little bit more than 1 minute before we get started. Obviously, for those of you online, same old story. For those of you who just came in online, though, my camera's not working, but that's okay. So you'll still be able to hear me, and you'll still be able to see the PowerPoint. I'll just try to point less at the screen with my hands and try to point more at it more with the electronic pointer on the screen, so you can actually see what I'm pointing at. Massey is here. Just joking. All right. All right. A little less than a minute now, and since we're recording, there's no real big announcements. Everything's just, I guess, reminders, nothing new. So your labs are due today. I still have to finish grading some of the last ones from last week. So, if you missed the deadline, don't just throw up your hands and say, oh, I missed it. Just go ahead and do it, because as long as it's in there before I get around to grading it, in my book, that's on time. Because, that's my reward to you for me being slow to grade. When I'm slow to grade, that's what's going to happen. Independent work, you should have about a little bit less than 22 points by the time we start the week next week. What else? Anybody have any questions? Okay, obviously, too, this is a good time to remind everybody, given all the technical difficulties I'm having this morning. I love giving you the online option because sometimes life happens. But if you right now. Speaking of which, I want to bring this up. So I've been looking at my students from past semesters, and I've always done like higher than the university average and a lot higher than the department average. But ever since COVID, it's gone way downhill. And I think it's because I just give you guys more reasons to be disappointed and upset with me. Back in the day, if you weren't in class, you were just absent, you didn't get the points. If you turned in something late, it was just a 0. If you turned something in, that was it. That was your grade. But now I give you these other options of being online, and I say, all right, if you turn things in late, you can get half credit and all that. So I have all these moments now where I have to give you bad news, like, sorry, you didn't get all the words, or sorry, you didn't get this in time. So I just seem like a real bad guy more often now because I'm constantly giving you bad news. So please keep that in mind. I'm just trying to give you more options. Anyway, any questions about how things are run in general before we jump back into biological molecules? Good. All right. So we're talking about disaccharides. That's where we left off. So to remind you, most of this chapter is going to be talking about 4 different types of biological molecules. The first one is carbohydrates, which this is part of. The second one, and maybe not in this order, I don't remember for sure, but the second one is lipids, and then we have proteins and nucleic acids. So those are the big four biological molecules that we're talking about. And under the category of carbohydrates, first we talked about monosaccharides, which are single sugars. Then we're here, what we're talking about now. And I need to stop pointing at the screen because they can't see that. So this is what we're talking about now, which are disaccharides. That's the last thing we talked about. We gave some examples to back it up. We talked about lactose, maltose, sucrose. Those are just examples. You don't need to know them for the exam. What you do need to know for the exam, again, is that disaccharides are made up of two sugars, hence the name, and that they fall into that category of carbohydrates. Your book also talks about high fructose corn syrup. I'm sure you've heard of it before. I'm not going to test you on it, but it is a good example because it's something that you deal with in your life. Anybody who drinks soda or a lot of foods have high fructose corn syrup because it's cheaper and sweeter than actual table sugar, which is, again, to remind you, I'll back it up, it is sucrose. So anyway, you can read about how it's made. You can write about it for independent work if you want to dive deeper into it, but I'm not going to ask you any questions about high fructose corn syrup. I'm not going to ask you any questions about this, but I like that your book points it out because this is also very relevant to your everyday life. Back when this book was published, and it probably hasn't changed much since then, the average American consumes about 130 pounds of sugar per year. So when you get a chance, next time you're at the grocery store, look at how much a bag of sugar weighs and then do the math and figure out how much per year. The average American. It's actually a lot because you get it in more places than you think. Like spaghetti sauce, you might not think there's sugar in there, but there is. There's added sugar. But anyway, long story short, it's bad for you, as you can see there. You can read about it. I'm not going to ask you any questions about it. That's just scratching the surface. Again, a good independent work topic. If you're into health things, you can look up some of the other ways that sugar is bad for you. Attendance words. Let's go with, hold on, let me fix this so I can circle it. Let's say the first word for attendance is going to be empty, right there, the word that I'm circling. And as a reminder, for those of you in person, you don't have to send the words. You'll get a little extra credit. Now, watching the live stream, these words before 9 a.m. Anything after that's going to be late. So make sure you send all the words before 9 a.m. And for those of you who are watching the video, yeah, we'll make it easy. It's a Friday. So you also send me the words, and the first word is empty. So any questions? All right. So again, this is better. This is what I should have started with. We're talking about carbs right now, as opposed to lipids or proteins and nucleic acids. So now we're finally going to get into polysaccharides. So if a monosaccharide is one sugar, and disaccharides are two sugars, this one's a little bit trickier, but not that much trickier. Are there any guesses to what a polysaccharide would be? 3 or more, right? Yes, that is technically correct. And as far as we're concerned, you can just stick with the more. It's more. Your book describes them as this. Polysaccharides are complex carbohydrates. So if you ever heard the word complex carbohydrates, that's what they're talking about. So when people talk, even actually in everyday terminology, I think when people use the word carbohydrates, this is usually what they're talking about. I think. Everybody's different. But usually when they say carbs or carbohydrates, they mean starch, things like that. But here's the important part as far as the exam is concerned, is this right here. Because remember, I told you, for all four of the molecules, carbs, lipids, proteins, nucleic acids, you need to know which one's the monomer, which one's the polymer. So to remind you, the monomer of a carbohydrate is the monosaccharide. Polymer is a polysaccharide. I wish they were all that easy. This would be so much easier. Like I wish proteins were amino acids and polyamino acids, but it's not like that. You'll see when we get there. Anyway, this is just an introduction to the polysaccharides. Are there any questions so far? Okay. If you download the PowerPoint, you can watch this video that shows this animation that shows, well, can anybody recognize what this is? Not specifically, but how about this? If it's a multiple choice exam, is this a monosaccharide, a disaccharide, or a polysaccharide? I don't expect you to know that, and this won't ever be on an exam to show you, but just so you know, just to refresh your memory, that's a monosaccharide. So a polysaccharide is linked in dehydrated. Anyway, there's different types of polysaccharides, and I'm going to teach you a few of them. You need to know the difference between them. The first one's starch. I'm sure you've heard of it. If you're taking notes, you could basically shorthand it. Like if you were going to make little flashcards, you could write starch, and on the back, plants. Of course, you still need to memorize, first of all, that starch is a type of carbohydrates, polysaccharides specifically. But when it comes to differentiating between the different polysaccharides I'm going to teach you, you can just associate starch with plants. So, you'll usually find them in the root parts, like potatoes, right? Or the seed parts, like corn, which makes sense because they use it for energy. Starch is what plants use to store energy. Bowers, right? Right. You don't need to email me this time because my attendance isn't working. So I'm taking attendance verbally, and then I'm going to watch the video later. Actually, that reminds me. Never mind. You guys go ahead and send me the emails if you don't mind, just in case. I'm not going to mark you as absent, but who knows? Again, technology is fighting against me today, so I think I'm recording me saying your names, but it might not be recording. Anyway, back to it. So that's starch. Again, for the exam, you need to know the difference between the three different types of polysaccharides. So you would need to know that starch is found in starch is found in plants, and it's used for energy storage. And why do we eat it? For the same reason, right? We're trying to get energy. So are there any questions about starch? All right. And again, another independent work topic, if you want to look it up. Where else can you find starch? I put potatoes and grains, right? So what are some other places you can find starch? Or maybe you could just break down that word grains. What are grains? There's a lot of different grains. All right, anyway, that's what it looks like. So there's an actual picture, scanning electron microscope picture. You need to stop pointing at the screen. They can't see that. There we go. So that's an actual picture of starch granules, and this is a little drawing of what they look like. So look, as you can see, it's just a little zigzaggy chain of glucose molecules all strung together, right? Which makes sense because, again, form and function, right? So each one of those little round things, that's a glucose, and that's what cells use for energy. When they need energy, they take one of those glucoses and they work some magic with it, and you learn about that in another chapter. So imagine this is just like a battery. Every time the plant needs energy, it just lobs one of those things off, uses it. And it lobs the next one off, and then it uses it, right? So it makes sense, the form and the function. The next one we're going to talk about is glycogen. You're going to need to know the difference between glycogen. And look, you can look at this picture. It looks a lot like what I just showed you. This that I'm highlighting right now looks just like starch, right? The only difference is it kind of branches out. So again, even though none of you are chemists, what this thing does by looking at it, but the whole form and function thing. And think to yourself, all right, that looks a lot like starch, but slightly different, which means that should tell you its job is a lot like starch, only slightly different. So any guesses where you might find glycogen? This is going to be more of a in context situation. Given what we've just talked about, and I told you starch was used for energy for plants, where do you think we might find glycogen? No guesses? Starch is for plants. Animals, good. Don't be shy. And I love wrong answers because then I'd love to know what you're thinking. So if you said dinosaurs, like, oh, I wonder why. And we could dive down that hole. And that would be a type of animal. But yes, glycogen is found in that. Starch is used to store energy for plants. Glycogen is used for animals. So again, and look at that. Look at the way it's shaped. It looks a lot like starch, just slightly different. Because it basically has the same job, just for a different organism, plant or animals instead of plants. Any questions about glycogen? It's another good independent work topic. So we eat starch, right? We eat saccharides from plants because we want energy. But we use glycogen as energy. So obviously there's some steps between us eating starch and us using glycogen. If you want to look that up for independent work, feel free. How do we get from starch to glycogen? And then later you're going to learn, we're going to take that glycogen and turn it into glucose, and then turn that glucose into pyruvate and a bunch of other stuff. So it's a lot of steps in between. So I'm going to put an X to these last three bullet points, not because they're not true or they're not important, But for the exam, you just need to know glycogen is used for animals for energy storage. But yes, it's mostly stored in the liver and the muscle cells because that's where we need them. And again, it's broken down to release glucose. Because just like I was talking about with the starch, each one of those little glucose, each one of those little green rings, that's glucose, right? So when your body needs energy, you just take one of those things off and use it, then take the next one off and use it, so on and so forth. Anyway, any questions about glycogen? All right. The last one that we're going to talk about for polysaccharides is cellulose. I won't ask you to guess this one, because the last one in context should have been able to guess it. Someone did. Cellulose is completely different. It's not even about energy storage, but just out of curiosity, does anybody know what it is? I don't expect you to. All right. Cellulose, first of all, is the most abundant organic compound on Earth anyway. You might need to know that. That might be some trivia. But more importantly, there you go. You could know it as this, fiber. Where are we at? Cellulose is fiber. So when people talk about getting fiber in your diet, that's what they're talking about. And your book also points out, even though I'm not going to ask you, that it cannot be broken down by enzymes produced by animals. So animals don't form, guys don't know really what enzymes are yet, but basically animals themselves cannot break down cellulose. We can't digest it. Of course, there's animals like cows that can digest it because they have the right things living in their stomach, but those are other organisms that are doing the breaking down. It's not the cows themselves. Also, certainly, you don't need to know this for the exam anyway, but basically, cellulose is what makes up the cell wall of plants, and that's why it's the most abundant compound on Earth. That's what plants are made of. When you look at a plant, mostly what you're looking at is cellulose. Of course, you're seeing a lot of green, which is chlorophyll, and that's what catches your eye, but that's the color. The shape, the physical stuff that you're looking at, it's almost entirely cellulose. So again, as a recap, for polysaccharides, we talked about 3 of them. Starch, well, hold on, there we go. Hold on. There we go. It's all right there. Right? So starch is the polysaccharides that plants use to store energy. Glycogen is the polysaccharides that animals use to store energy. And cellulose is what plants use for structure. So those are the 3 things you're going to basically need to know for the exam for these 3 things. Anyway, any questions about that? Before I back up, because I skipped some slides on purpose. By lying or bending the truth. I found this even looking for it. What's in your fast food? Now, first of all, let me tell you this. Fast food is bad for you, right? Everybody knows that. I'm not here advocating for fast food. It's not good for you. But it's not as bad. They're trying to make it out right here, or at least not for these reasons. So if you look here, where'd it go? Wood, yeah. This is such a stretch of the truth. It says that there's wood in your food at fast food restaurants. And it's true in a sense. This part's true. What's the part that says cellulose? That's true. There is cellulose in your food and fast food and all the other food you buy, because you know what? Cellulose is actually good for you. So the reason they're lying or stretching the truth is because there is cellulose in wood. That's what makes up wood. But there's also cellulose in spinach and lettuce and potatoes, right? So cellulose is good for you. You need fiber, but people try to scare you by making false equivalencies. So it's really stupid. Anyway, you could look up where else you can find cellulose, but that's pretty much it. Any questions about that? All right. Again, independent work topic if you're interested. What are some of the polysaccharides? So again, we've only talked about starch, glycogen, and cellulose. There's some other ones that are fairly important for biology. And that ends the discussion on carbohydrates. So that brings us to the next big one, which is lipids. Yeah. So that'll be the next attendance word too, as a matter of fact, lipids. There we go. So for all of you, again, if you're in person, you want the extra credit, send the words by 9. If you're online live streaming, send the words by 9 for any credit. And if you're watching the video, make sure you send the words. And in this case, take a screenshot of the word where it says lipids, where I circled it. All right. Anyway, any questions? And I know for those of you who have not screwed things up, you're probably getting tired of me constantly repeating that. But I still have people sending me emails at like, 11:30 saying, here's my attendance words. And I feel bad, but I'm like, that's too late. Can you? I won't. Never mind. Anyway, let's talk about lipids. They are also something we call hydrophilic. Carbs are hydrophilic. You need to know that they are hydrophilic, and you need to know what hydrophilic means. Basically, it just means they dissolve in water or they like water. Either way you want to put it. They mix with water. All the different ways of saying that. Technically, it means water-loving in Greek, hydrophilic, water-loving. So yeah, you can think of it in those different ways. Dissolves in water, likes water, mixes with water, however you want to put it. The opposite of that is hydrophobic, and that's what lipids are. Lipids are hydrophobic. They do not dissolve in water. They do not like water. They do not mix with water, however you want to put it. So hydrophobic and hydrophilic things do not mix. And generally speaking, hydrophobic things mix with each other. Right? So different things, hydrophilic things, different hydrophilic things will mix with each other. But they won't. Hydrophobic and hydrophilic do not mix together. That'll be important later in the semester. Your book uses this example, so I'm going to put it next to it because it's just an example, so I'm not going to ask you about it. But I'm sure you guys have seen oil and vinegar or even like Italian dressing, right? And you can see that it's separated. And you can't molecularly mix it. Now, you can shake it. So to the human eye, it looks like it's mixed. And to your taste buds, it seems mixed. But it's not mixed at the molecular level. That's called each other, but they seem mixed because you shook it up. So questions about hydrophobic versus hydrophilic. And again, that will be important later in the semester. Okay, so there's nothing to write down on this. I'm not going to test you on it, but it's a good thing to clarify here that lipids are different from carbohydrates, which we just talked about, and proteins and nucleic acids, which we're going to talk about next, because technically they're not what we call huge macromolecules. Remember polysaccharides, I just showed you pictures of it, just long strings of glucose, right? They're really large. And then you'll see when I show you proteins and nucleic acids, also really, really, really large. So relatively speaking, these fats are not as large. But again, I'll talk to you about that. It's just pointing that out. They're also technically not polymers built from repeating monomers. So again, when we talked about polysaccharides, right, that was just glucose, just a bunch of strings of glucose, or that glycogen, or even the cellulose, right? Those are repeating monomers. Now, fats, as you're going to see when we get there, they are made up of different parts, but it's not like just the same repeating parts. And again, I'm going to put it next to that because I'm not going to ask you about that. And then finally, your book points out that lipids are a diverse group of molecules that are made from different molecular building blocks. So again, as opposed to repeating monomers, they have different parts. Actually, and again, even though I'm not going to test you on this last bullet point, that might help you remember something, right? So if I describe one of these molecules, say it's made up of this, this, and this, you should think, oh yeah, that must be a lipid. Because that's the only thing we talked about that's made up of different parts, as opposed to repeating monomers. For example, I'm about to teach you about triglycerides, which are made up of 3 fatty acids, and they all stick together. So even if you don't remember that, it's like you forget that that's actually a triglyceride, and that's okay. As long as you remember, all right, we're dealing with different parts, must be a lipid. Anyway, are there any questions so far? All right. So just like when we were talking about carbs, we talked about different types, right? We talked about monosaccharides, disaccharides, polysaccharides. And then even when we were talking about polysaccharides, we talked about 3 different types of those. Same here. So when we're talking about lipids, we're going to break that down into 2 basic types, fats and steroids. And as you might guess, fats first. I think most people think of when they use the term fat, they're probably talking about a triglyceride. And you do sort of need to know this. Of course, it's a multiple choice exam, so when you're studying, don't feel like you're not going to have a test question that says, name the 3 parts or name the parts of a triglyceride. I'm not going to ask you that, but again, it might be multiple choice. You should be able to recognize this as a triglyceride, and it's made up of a glycerol molecule joined with 3 fatty acid molecules, and I'll show you a picture of it soon. But again, like I said, those are different parts, right? You have fatty acids and you have glycerol. That it's a lipid and not the other ones that we talk about. Fatty acids are long and energy rich. That's good to know. Not going to be a test question. We talked about that at the beginning of the chapter when I showed you a picture of what octane looks like, right? The molecule in your gasoline that burns, and how it looks a lot very similar to fatty acids, right? Just a bunch of long strings of carbon with hydrogens attached. Same, similar form, similar function, right? Also, and your book's not going to, or I'm not going to ask you about this either, but your book points it out. They are twice the energy of carbs. As a matter of fact, and I don't even remember if your book specifies or not, but if you want, you can look this up for independent work. When I say twice the energy of carbs, what do I mean? Like per weight, per molecule? What? Like, what does that mean, twice the energy of carbohydrates? And as you probably know, they are stored in adipose cells. And again, I'll put an X to that because I'm not going to ask you. You might not know what adipose cells are, but you probably know that fats are stored there. Does anybody know what adipose cells are? If you're into nutrition, you should. It's these things right here. So things that are keeping me warm in the winter. And if you're online, you can't see it. It's fat cells. Adipose cells are fat cells. So again, when you think of fat, and when people talk about fat, this is usually what they're talking about. Either when they're talking about dietary fat or the fat that's on your body. That's what it is. Anyway, are there any questions so far about fat? We have more to talk about, but all right. This is what it looks like. Well, sort of. These are the three different parts. These are the different parts I was telling you about, right? The 3 fatty acids and the glycerol. So again, those aren't repeating monomers. Those are different parts that are brought together. So if you download this PowerPoint, you can watch the animation that shows you those things coming together. What kind of reaction is going to bring those things together? Yes, dehydration. Because again, in this whole semester, when we talk about chemical reactions that build something up, that's a dehydration reaction. Anyway, that's what it looks like. So you can see up top right here, like I said, dehydration reaction. Why? Well, because you're forming a molecule of water. You're taking a water molecule out of the reactants. But anyway, down here, this is what it looks like, right? So that's what a finished fatty acid looks like. I will point this out before we move forward. Notice that there's like, let's see, this one's really long and straight, right? Excuse me, this one's, let's just call it straight. This one's longer and straight. This one's even longer and bent down, right? So before I move forward, I want to point out that this is just a fatty acid. They don't all look like that, right? So there's 3 different fatty acids. They all have 3 fatty acids attached, but the length and the shape of those fatty acids is always different, right? So it's not always going to be, short, long, short, straight, long, straight, and long curve, right? It's not always going to be like that. And that'll be important here in a few seconds. Any questions yet? All right. What are the essential functions? So we know, for example, glycogen is used to store energy in animals. Starch is used to store energy for plants. Cellulose is used for structure in plants. So what are fats used for? I'm sure you guys know. Even I bet if this wasn't in a biology class and some second grader came up to you and said, hey, what are fats for? I bet you can answer it. So try to get your mind out of the fact that we're sitting here in biology. What's fat used for? And the picture is one of the hints for one of them. Insulation's good. Of course, yeah. What is it? Storage, yes, because we already talked about that. I already actually gave you that one, right? So storage, you said, like energy storage, right? So those adipose cells, those fat cells, that's insulation and it's storage. And then there's one more, and this is more of what this picture is. And it's for those of you who don't know what I'm getting at here with this picture. This is the fat. So you have fat on your feet. So what do you think that's used for? Protection, yeah. More importantly, or I shouldn't say more importantly, but as your book puts it, cushioning. So yeah, you need to know that. We're talking about triglycerides. It's used for energy storage, cushioning, and insulation. And that should be easy to remember because energy storage, obviously, like if you eat a bunch of calories and don't burn them, you get fatter, right? Because your body's storing that energy. Cushioning, that makes sense. You forget it, pinch the bottom of your foot. Or pinch someone's butt. No, just kidding. Don't pinch someone's butt. Pinch your own. But that is also what that's for, right? That's cushioning. That's one of the reasons why you've got more of it right there on your bottom, because that's where we sit. And of course, insulation. That's a little bit less easy to remember because generally speaking, humans, we don't deal with that, right? Usually when we get cold, we can throw on some clothes or adjust the temperature. But for other animals, like polar bears, for a great example, they need that fat as insulation. Another interesting independent work topic if you want, right? So what are some animals that really utilize fats for insulation? I think it's interesting. Plus, there's cultures in different parts of the world that eat fat, like whale fat and walrus fat, and somehow they're healthy. So it's interesting stuff to look into if you're into it. Any questions about triglycerides or fats? All right. Here's where it gets a little bit more complicated. I'm sure you've heard the term saturated versus unsaturated, and you may have wondered what it is, and now I'm about to tell you, and now you're going to need to know for the exam. If it's unsaturated, well, first of all, let's just start with saturated. Sorry, I should have done those in different orders. If something is saturated, if it's a saturated fat, what we mean is it's saturated with as many hydrogens as you can put on there. So if you're not in biology class, when you think of the word saturated, what do you guys think of? Curious to see if anyone thinks what I usually think of when I think of saturated. No one? All right. When I think of saturated, I think of like me cutting the grass or much soap that it won't absorb anymore. It's right. That's saturated because it's as much sweat as that thing could. Same thing here, except now we're talking about hydrogen, not sweat. So up top here, you can see right here, this saturated one has as many hydrogens as possible, and that's what it's saturated with, and that will be a test question. What is a saturated fat saturated with? Hydrogen. So then, obviously, unsaturated fats don't have all the hydrogens they can have. And why? And the answer is right here, because some of those carbons are double bond. And as I'm sure you're familiar with from lab, there used to be hydrogens right there, right? Or there could be potentially hydrogens right there, but there's not because there's a double bond. See, the way I have it drawn right now, that carbon has too many bonds and that carbon has too many bonds. Saturated and unsaturated. So are there any questions so far about the difference between saturated and unsaturated fat? All right, and the next word for attendance. I'm not even going to say it this time. Let's make it a little bit trickier. So if you're online, you've got your eyes closed, you're not paying attention, open them up because there's your next word for attendance. All right, any questions about this? Okay, let's dig deeper into it. You might need to know this. I'm going to put a question mark indicating that. I'm not sure if I'm going to ask you or not. This is definitely useful for your day-to-day life. Most animal fats are relatively high in saturated fat. So basically, and there are some exceptions, when you think of saturated fat, you should associate that with animals. And there's a reason, and I'm going to put an X to this because I'm not specifically going to ask you what I'm about to tell you, but what I'm about to tell you will help you remember why saturated fats are bad. And that is this bullet point right here. They easily stack up. So remember, saturated fats, I see some note taken, but here in a second, I'm going to back up another slide to show you that slide I showed you earlier that shows what a saturated fat looks like. All right. So again, here we have a saturated fat up top. Imagine trying to stack a bunch of those. It'd be pretty easy, right? Just a bunch of flat things. It'd be like stacking lumber. Nice and easy. Even if they're different lengths, right? They can stack on top of each other pretty nicely. Unsaturated fats, right? They all have different lengths, different curves. Sometimes they curve once, like this one shown here. Sometimes they curve twice. Sometimes the curve goes up. Sometimes the curve goes down, like it's shown in this picture. Sometimes the curve might be at the beginning of the molecule. Sometimes it might be at the very end, right? So there's all kinds of different ways that an unsaturated fat can curve. So imagine trying to stack a bunch of those things together. At the molecular level, they're just not going to fit together. And that's why they don't get solid as easily, right? And because of that, that's why saturated fats are generally bad for you, but you do need to know this bullet point. Of course, not necessarily the word for it. You just need to know that saturated fats are generally bad for you. Why? Because they build up in your blood vessels. To help you remember that they build up in your blood vessels, just remember saturated fats are nice and flat. They just kind of stick on top of each other. They fit together nicely at the molecular level. Anyway, any questions about this slide? All right. So let's talk about the opposite. If most animals you should associate with saturated fats, or saturated fats you should mostly associate with animals, the opposite can be said for unsaturated. So usually when you think of plants, and actually fish as well, they're high in unsaturated fats. And there are some exceptions, hence that picture of a coconut. And you can look up why. There's reasons why coconuts are higher in saturated fats. And you can look it up if you want. But anyway, there's some examples of fat. Obviously, we need fat in our diet. Saturated is generally bad for you. Unsaturated is generally good for you. Now you know why. Oh, yeah, also it's liquid at room temps. I'm not going to ask you that, but the reason it's liquid at room temps, like I was saying earlier, they don't fit together nicely, right? Unsaturated fats don't fit together nicely at the molecular level. So they're not settling down. So they're always moving, and it makes it liquid as opposed to something like something thicker. Anyway, any questions about that? All right, I'm going to put a big old X to this. This is just from your textbook. I'm definitely not going to ask you this. This isn't a culinary class or a health class, so you don't need to know the differences between corn oil and palm oil and butter. But you can look it up if you want. There's more than this. How many of you cook, like consider yourselves pretty good cooks? Anybody? No? Okay. Well, you use different oils for different purposes for this reason. Like there's different smoke points. Like some of them smoke before others because of reasons like this. And if you're interested, you can look that up for independent work too. So again, I'm not going to ask you about that. It's just an example. If I were to ask you anything about this, I would give you this picture and then ask you a question just to make sure you can understand graphs. So I might give you this picture and say, well, which of these three has the most saturated fats? And you can look and, oh, yeah, butter at 58% as opposed to palm oil with 50 or corn oil with 13. Everyday life. Food manufacturers very often convert unsaturated fats to saturated. So they change them from relatively healthy to relatively unhealthy. How do they do it? Well, if unsaturated doesn't have all the hydrogens it could, then logic should tell you they do it by basically putting in the hydrogens. And that is a process called hydrogenation. I will put an X through this, meaning that I'm not going to specifically ask you what hydrogenation is. But you should still know the word just in case I do ask you about trans fats and talking about going from saturated to unsaturated. Why do they do it? Well, right, because when you think about it, food companies, if they're trying to make a profit, why put an extra step in there? That's just going to cost more money, more materials, more labor, more time. But they do it for a reason, because when they do that and we get these trans fats, they don't spoil as quickly. They're good for frying things, and they're solid at room temperature. So like Crisco, right? I don't know if you guys have ever seen that. It's white goop. Even bacon grease, of course, that's different than this because that's natural, but still, bacon grease, right? It's solid. If you've ever seen anybody cook with it, it's solid, and you can scoop it out with a spoon, like a big chunk of solid stuff, put it in your frying pan, and it turns liquid. But anyway, if anything, you need to know trans fats. They're not natural. They're bad for you. Those things don't always go together. I'm not saying they're bad for you because they're not natural. I'm saying those two different things. Trans fats are not natural, and they happen to not be bad for you. Those are not always, they don't always go hand in hand. Like I said before, there's a lot of natural things that are bad for you and a lot of unnatural things that are good for you. Anyway, any questions about trans fats? Obviously, we've just scratched the surface. You could, if you're into it, look it up for independent work. Where are some other places you can find trans fats? Why are they so bad for you? I just told you they're bad for your health. Why? Do they make you go bald? Do they grow extra toes? Do they increase your risk of getting COVID? Like, what is it? How's it bad for you? Look it up if you want. Speaking of different types of fats, there's also one called omega-3 fatty acids. These are the ones that are good for you. They're healthy. Your book scratches the surface by saying they reduce heart disease, arthritis symptoms, and irritable bowel syndrome. And they're mostly found in oily fish and nuts. I actually take it. I take fish oil pills. It's good for you. And again, your book just scratches the surface. You can look into it for independent work. How else are omega-3 fatty acids good for you? Also, it says found in oily fish. So what are oily fish? Like you guys, no one said that they cook here, so I would assume. How many of you are deep sea fishermen out in the Pacific or the Atlantic? Just the one. I'm just kidding. Right? Yeah, so none of you, right? So I assume none of you are ichthyologists. None of you are fish experts. So, that might be something you can look up. What are some fish? What are oily fish? Anyway, there's a little infographic showing a lot of the stuff all the stuff we talked about. Saturated fats, unsaturated fats, trans fats, omega-3 fats, plant oils. Any questions? Okay. The next major category of lipids, the last major category of lipids that we're talking about are steroids. I'm sure you've heard of steroids. A lot of this is going to be a review. Steroids, they're different from fats. They're still lipids, but they're not like fats because they have a different form and a different function. There we go again with the form and function, right? Structure and function, however you want to say it. So remember, we got 3 triglycerides stuck together on the, 3 fatty acids stuck together with a glycerol for fats. Here it's something completely different. 1, 2, 3, 4 rings. That's all we have, 4 rings. There's like 99.9% chance I'm not going to ever show you a picture and ask you to identify something. But if I did, if you were to see those 4 rings, you'd be like, oh, that's a steroid. And spoiler alert, I'm not going to show you some different version of 4 rings as a trick. Like I'm not going to show you, so you can see these hexagon, 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 pentagon. That's for a reason. That is the shape. But it's not like I'm going to show you pentagon, hexagon, hexagon, pentagon, and expect you to catch that mistake, right? You should just recognize that as a steroid. So if all steroids have that one shape, then how are they different? And that's where this point comes in right here. They vary in function because they vary in their functional groups. So all the little things that I'm going to show you later that are attached to these things, that's what makes them different from each other. But that is the base of what a steroid looks like. 4 fused rings. So if this wasn't a biology class and I said, what is steroids, what would you guys answer? What do you think of when you think of steroids? Especially the athletes. I would hope you would at least, usually people who are athletic also follow athletes, professional athletes. So does anybody have any guesses? What do you think of when you think of steroids? What is it? We'll talk about it. I used to think, usually to this day, what I think of when I think of steroids is like Pred Packs. I don't know if you guys have ever had that prescribed to you, like for poison ivy or something. So when I think of it, I think of prescribed drugs, but we'll come back to that. Here's one thing you should think of, and I don't think most people think of it that way, but cholesterol. You need to know that. Cholesterol is a type of steroid. So know that cholesterol is a type of steroid. See, most people don't think of that. We all know that cholesterol is the good type, is the bad type. Generally, when people talk about cholesterol, they talk about the bad stuff. But what you do need to know, I guess the second bullet point is more important than the first. It is the base steroid. So all steroids are basically made by using cholesterol. So we take that basic cholesterol, which you can see right here up top, and you can see that there's those 4 rings, but that's the cholesterol. And then they just make some changes to it to make the different other steroids. And can anybody guess what these 2 steroids are? We've got steroid A and steroid B. The pictures of the animals should give you the hint, because I doubt, again, none of you are chemists, so I don't think anybody's looking at the picture of the molecule and say, oh yeah, I know what that is. But given the pictures of the animals, can anybody guess what steroid A is? All right, when you think of males versus females, good. Yes, testosterone on the left, estrogen on the right. I'm not going to ask you about that. But yeah, also it's interesting to think, especially right now, there's a lot of talk about gender and sex, which are 2 different things, by the way. Sex is a biological thing, gender is not. But anyway, if we're talking about sexes, it's interesting to think, and you're going to learn later about the chromosome basis of it. Look, that's one of the big differences between males and females, is this right here. Testosterone versus estrogen. And let's see, what are some of the differences? Here we have a double bonded oxygen. Here we have a single bonded oxygen that has a hydrogen on the other side. What else? Same thing here. Here we have a double bonded oxygen. Here we have a single bonded oxygen with a hydrogen on the other side. And that's it, right? All the big differences between males and females, a lot of it is boiled down between those oxygens, right? And there's still oxygen, even on both of those. It's an oxygen versus the oxygen. The question is it double bonded or is it there's a hydrogen on the other end? Interesting stuff. And again, you can look into that if you want for independent work. Look up all the different differences between the sexes because it's not as simple as male versus female. We'll talk about that throughout the semester. Anyway, like I was getting at earlier, I was asking you what do you think of when you think of steroids. I think usually people think of this, which are synthetic anabolic steroids. That's basically the stuff that people use to cheat or to get larger. But there are some actual uses for it. For example, it treats diseases such as cancer and AIDS. So basically anything that destroys your body, in a sense, right? It's used to kind of help counteract what the disease does. But anyway, I'm going to put a big old X to this. I'm not going to ask you about synthetic anabolic steroids. But again, I think when most people think of steroids, this is what they think of. So just remember, for the exam, or for when we're talking about biology, when we're talking about steroids, yes, this is a steroid, but there's also the other ones. Cholesterol, estrogen, testosterone. Look up some other ones if you want. But yeah. Again, I'm not going to ask you about this either, but your book pointed it out, so I wanted to include it. What are some of the side effects of steroids? You got roid rage, depression, liver damage, high cholesterol. Makes sense, right? Because it's made from cholesterol. Shrunken testicles. Well, that's only for the males. Reduced sex drive, infertility, so on and so forth. And again, I'm not going to ask you the side effects of anabolic steroids. Any questions? All right. So that's it for the conversation with lipids. That brings us to proteins. This is perfect. We've got about 6 minutes left. So what I want to do is give you the introduction to proteins. And then when we come back and let that marinate over the weekend, and then when we come back on Monday, we can actually get into the meats and potatoes of the proteins. Proteins, what are they? Again, remember I told you need to know the monomer and the polymer for everything, right? For the carbohydrates, for the lipids, for the proteins, for the nucleic acids, monomer, polymer. So I'm telling you right now, they are polymers of amino acids. So again, you need to know that for the exam. What are the monomers for proteins? Amino acids. So in a sense, especially when you're not in biology class, in a sense, amino acids and proteins are the same thing, in a sense, because it's the amino acids that make the proteins. So if someone says, look, I'm taking these supplements, my doctor says I need some more or I don't know, the doctor says you need more proteins, and you tell some of your friends, like, well, here's some amino acid supplements. I'm like, no, my doctor said I need proteins. And you can explain to them, what's in this context, it's the same thing. So I told you, and you need to know this because I keep saying it, your cells are mostly water, right? 70 to 95% water. However, if you were to take all the water out of your cells, then over half of it would be protein. And again, you guys aren't biologists, but just knowing that there's so much of it should tell you it is very important. It must be important. If that's the majority of your cell other than water, then that should tell you proteins are important. And they are. You're going to learn about so many proteins throughout this semester. So this is a very important conversation. Right now, you're just learning it in the context of proteins. How are they different and how are they the same as the other biological molecules? But throughout the semester, there's going to be so many important proteins you learn about. Which brings you to that other bullet point, right? They're instrumental in almost everything cells do, and they're the most sophisticated molecules in the body. We'll put a big old X to that because I'm not going to ask you that on the exam. This is just like a preview. It's like, why are we even talking about proteins? Well, that's why. They make up most of our cells other than water, and they're very important. Almost everything they do is because of proteins. Actually, any questions so far? All right. How about this? Before we move forward again, if you weren't in biology class and you're thinking of protein, what do you think of? Of course, that picture might plant some ideas in your head. Of course, that's what I think of. When I think of protein shakes. Anybody? Protein? All right. Well, here's some examples. You don't need to write them down. You got structural protein, right? So hair, fingernail, horns. That's structural protein. You have storage proteins. So seeds, you'll find a lot of those in seeds and eggs because they're storing what you're going to need to grow, right? To make more protein, you need amino acids. So there you go. Then there's the one I think a lot of people think of when they think of protein, which is this, right? Muscles. So you need to eat protein to make muscles, right? Because, well, of course, in this case, that protein that you need to eat, it is a muscle. Then, of course, you have some, these are the really important ones for this semester. But no, this one's slightly important. Transport proteins, we'll talk a little bit about these later. So for now, I'm just going to tell you they exist. We'll talk about what they do in a different chapter. And really, really, really important for later in the semester are the enzymes. Enzymes are so important in the context of this course, because they do so much of what I'm going to teach you about. Without these enzymes, none of the stuff, or most of the stuff I teach you, wouldn't happen. And again, you need to understand how those enzymes work when I teach them to you. So to understand how any enzymes work, you need to understand how proteins work, which is what we're going to talk about. So we'll scratch the surface today. So again, sorry, I know you guys are ready to go. How about this? The last word for attendance will be, I'm going to do it again. I'm going to circle it instead of say it. That's the last word for attendance. If you're in person, you can send me those words for extra credit. If you're online, send me those words for your regular old attendance, not extra credit, but for your attendance before 9 a.m. And if you're watching the video, again, send me this word, take a screenshot of it as well. And that's it. We'll just get out of here a little early. Any questions? All right. Anybody who wants to stay back for a picture with the red shirts, feel free. Anybody who wants to take the picture for extra credit, feel free to stay back. And that is it for the day. You guys have a great weekend.